Hello, and welcome to Science Night Tales. I am glad you have found this quiet moment to drift. Tonight, we are going to leave the surface behind. We often think of the ocean as waves and beaches, but that is only the thinnest skin of a much deeper world. Most of our planet is hidden in permanent darkness, under pressure that would crush steel. Yet, it is teeming with life. We are going to descend slowly, layer by layer, from the sunlit shallows to the crushing silence of the abyss. We will meet creatures that glow in the dark, ecosystems that feed on chemicals instead of light, and a stillness that has lasted for millions of years. You do not need to hold your breath tonight. You are safe to observe from a distance. You can simply let the weight of the water wash over you. If this perspective helps you find calm in the depths, you are welcome to like or subscribe. For now, let go of the air and let's sink together. Most of the space where life can exist on Earth is not on land. It is beneath the surface of the ocean. From the shoreline, from a boat, from the air, the ocean often looks flat and familiar. Waves move across the surface, light reflects and breaks. It feels like a boundary. But the surface is only a thin upper layer. Below it, the ocean extends downward for kilometers, layer after layer. A vertical space that is far larger than it first appears. If we could measure Earth not by area, but by volume, most of its living space would be found here, in water, in depth. This depth does not begin abruptly. There is no edge where the ocean suddenly becomes something else. It begins gently, just beneath the surface, where sunlight still moves freely and water remains warm and clear. From there, it continues downward at a slow and steady pace. Light fades gradually. Pressure increases in small increments. Temperature shifts by degrees, not extremes. Nothing sudden, nothing dramatic. This descent is not a drop, it is a continuation. At the surface, water is constantly in motion. Wind transfers energy downward. Waves form and dissolve. Currents begin to take shape. Sunlight penetrates the upper layers, scattering and refracting as it moves. Colors remain visible. Shadows soften rather than disappear. This is the zone most familiar to us. It is where human activity stays concentrated. Ships pass overhead. Diving equipment still functions easily. Yet, even here, depth is already present. Even here, the ocean is already layered. As we move lower, the change is subtle. Light becomes less direct. The water absorbs more energy than it reflects. Movement slows. Pressure begins to register, not as force, but as presence. Each meter adds weight. Each layer holds more water above it. There is no sensation of danger in this change, only accumulation. Time behaves differently here as well. Surface waters respond quickly to weather and season. Below, changes unfold more slowly. Heat travels downward at a measured pace. Chemical gradients form and remain stable. Particles drift and settle. This vertical structure is one of the ocean's most defining features. Not distance across, but distance down. The deeper we go, the more consistent the environment becomes. Less affected by storms, less altered by daily cycles. Sound travels farther. Motion becomes smoother. The water feels heavier, not in weight, but in stillness. This is not emptiness, it is density. The ocean does not compress its complexity into a single place. It distributes it by depth. Each layer holds its own conditions, its own balance. Above, energy arrives constantly from the sun. Below, energy arrives slowly, filtered and diminished. Life adapts to these gradients, not through speed or force, but through fit. Forms match conditions. Processes match availability. Yet this is not something that must be understood all at once. There is no need to anticipate what comes next. This descent does not ask for attention. It allows it. Water grows cooler. Light softens further. The color spectrum narrows. Blue light persists longest, traveling deeper than other wavelengths. Red fades first, then yellow, then green. What remains is a calm, dim clarity. The ocean's depth does not announce itself. It reveals itself gradually, through repetition and continuity. Currents still move, but more slowly. Particles drift downward, settling over long periods of time. Some will take years to reach the bottom. This slow movement creates a sense of scale that is not visual, but temporal. Depth measured not just in meters, but in duration. From the surface, the ocean can seem restless. Below, it becomes patient. Pressure continues to build, evenly distributed in all directions. There is no single point of strain, only uniform increase. Water supports itself. Each layer bears the weight above without collapse. This is one of the quiet achievements of the ocean. Stability through balance. The deeper layers do not compete with the surface. They exist beneath it, sustained by it, and largely unchanged by daily motion above. As depth increases, familiarity decreases, but calm does not. There is no boundary that separates the known from the unknown, only a gradual shift from what is commonly seen to what is rarely observed. The ocean holds this transition without emphasis. It does not mark it with lines or edges. It simply continues downward. The surface is a beginning, not a center. The true extent lies below. This is where most of Earth's water resides. This is where most of its stable environments exist. This is where time moves at a slower pace. Descending through the ocean is not a search, it is a progression. Each layer prepares the next. Each change is small enough to feel natural. Light thins but does not disappear. Movement slows but does not stop. The water remains present, surrounding and supporting everything within it. As depth increases, the sense of direction changes. There is no horizon, only down measured gradually. Distance becomes vertical rather than horizontal. Space becomes column rather than plane. This vertical world has existed for hundreds of millions of years, long before observation, long before measurement. It continues now, unchanged in its fundamental structure. The surface will always be active. Below it, the ocean remains consistent. This consistency is what allows depth to accumulate, what allows layers to persist. Nothing rushes here, nothing demands. The descent continues at its own pace, and just beneath the surface, where light still reaches and water still warms easily, the first layer begins to give way to the next. Not with a break, not with a signal, just with a slight change in brightness, a slight increase in pressure, a quiet transition into deeper water. Just beneath the surface, the ocean enters its first and most familiar layer. Here, sunlight still moves freely through the water. It arrives from above in broad bands, spreading downward, weakening slowly as it travels. The upper ocean remains bright, clear, and active, not because it is shallow, but because energy is constantly arriving. This is where most of the ocean's usable energy begins. Sunlight penetrates the surface and continues downward for tens of meters. Not all light travels equally. Some wavelengths are absorbed quickly, others pass through more easily. The result is a gradual filtering rather than a sudden loss. At this depth, light is still strong enough to support photosynthesis. Microscopic organisms convert light into chemical energy, forming the base of the ocean's food systems. This process happens continuously, evenly distributed across vast areas. Nothing about it is sudden. Nothing about it calls attention to itself. The surface waters remain in constant motion. Waves move energy horizontally. Currents transfer heat across large distances. Warm water rises, cooler water sinks. These movements are not chaotic. They follow physical rules shaped by temperature, salinity, and the rotation of the planet. The result is a steady circulation that redistributes energy without interruption. Heat enters the ocean here as well. Sunlight warms the upper layers, increasing molecular motion. That warmth does not stay in one place. It spreads outward and downward, slowly blending into cooler water below. This exchange creates stability rather than imbalance. The ocean absorbs heat gradually and releases it slowly. The surface zone acts as a buffer, smoothing changes rather than amplifying them. Life is more visible here, but visibility does not mean importance. High biological activity occurs because energy is readily available, not because conditions are dramatic. Organisms function efficiently within predictable boundaries. Movement is common, but not hurried. Schools form and disperse. Plankton drifts rather than swims. Growth follows seasonal patterns tied to light and temperature. This layer feels familiar because it behaves in ways we recognize. Light arrives from above. Heat spreads outward. Motion responds to wind and gravity. Yet even here, depth is already present. Below the surface zone, light does not stop. It continues downward, but with reduced strength. Each additional meter absorbs a small fraction of what remains. This loss is gradual enough to feel continuous. There is no clear dividing line where brightness ends and darkness begins. Instead, illumination thins slowly and evenly. Pressure also begins to increase, though it remains unnoticed at first. Water presses inward from all directions. The force is balanced, constant, and evenly distributed. Temperature changes follow the same pattern. Near the surface, warmth fluctuates with time of day and season. As depth increases, these variations diminish. The water becomes more stable, less responsive to surface changes, more insulated from short-term variation. Surface currents still influence this layer, but their reach is limited. Wind-driven motion weakens with depth. The water below responds more slowly, preserving momentum over longer periods. Particles suspended in the water begin to drift downward. Some will remain here briefly. Others will continue sinking over days, months, or years. This slow downward movement connects the surface to deeper layers. Material produced in sunlight does not remain confined to it. It transfers downward, one small step at a time. The sunlit zone functions as an entry point. Energy enters here, heat enters here, material begins its descent here. Nothing is forced, nothing is rushed. The system remains open and continuous. Even as life density decreases with depth, structure remains. The ocean does not collapse into simplicity below the surface. It reorganizes. Light becomes less intense, but still directional. Heat becomes more evenly distributed. Movement becomes smoother and less turbulent. The familiar begins to give way to the unfamiliar, but without disruption. This upper layer does not end abruptly. It transitions. As light continues to weaken, colors change subtly. Brightness softens. Shadows lose definition. Photosynthetic activity becomes less efficient. Energy production slows. Biological systems adjust accordingly. The water remains clear, but quieter. Motion persists, but with less surface influence. This change happens slowly enough that it feels natural. There is no signal to mark the shift, only a steady reduction in light and warmth. The sunlit zone fades not because it stops functioning, but because its defining condition, direct sunlight, becomes less available. What follows is not absence, but adjustment. And as the last strong traces of surface light begin to thin, the ocean prepares for its next layer, where illumination no longer dominates and depth begins to shape the environment more than the sky above. As the descent continues, sunlight does not disappear all at once. It thins. The brightness that once filled the water now arrives in smaller amounts, spread over greater depth. Light still travels downward, but it no longer dominates the environment. Its direction becomes less defined. Its intensity softens. This is the region where the ocean begins to change its character, not through loss, but through reduction. Colors fade gradually. Red wavelengths are absorbed first, then yellow, then green. What remains is a muted blue tone, evenly dispersed, without sharp contrast. Objects no longer cast clear shadows. Edges blur. The water takes on a uniform appearance, calm and consistent. This layer is often called the Twilight Zone because light is still present, but no longer sufficient to shape the environment on its own. Here, illumination becomes background rather than driver. Photosynthesis slows and then ceases. Energy from sunlight no longer enters directly. Instead, life relies on what drifts downward from above. Particles sink slowly through the water column. Organic material produced in the upper layers continues its gradual descent, feeding processes below. Nothing arrives in large amounts. Everything comes steadily over time. Pressure continues to increase, though still evenly distributed. Each additional meter adds weight, but not strain. Water supports itself, balancing force in all directions. Temperature decreases as well. The warmth retained near the surface becomes more stable, less influenced by daily cycles. Here, temperature changes are measured over long periods rather than hours. Movement slows. Surface-driven currents lose their influence at this depth. Water still moves, but with less turbulence. Flows become smoother, guided more by density differences than by wind. This creates a quieter environment, not silent, but steady. Organisms here reflect these conditions. They are not built for speed or rapid change. They function efficiently within narrow ranges of light, temperature, and pressure. Vision adapts to low light. metabolism slows. Energy use becomes conservative rather than abundant. There is no sense of struggle in these adjustments. They represent balance rather than resistance. Life here does not compete with darkness. It operates within reduced light. Population density decreases, but structure remains. Food webs persist, supported by slow, continuous input from above. The water column becomes more layered. Chemical gradients stabilize. Oxygen levels shift gradually rather than abruptly. Everything unfolds at a measured pace. As depth increases, the ocean feels less responsive to the surface. Storms no longer register. Waves have long since dissipated. What remains is a consistent environment shaped by internal conditions rather than external forces. Sound travels farther here. Without surface noise and turbulence, vibrations propagate more smoothly. Movement is perceived over longer distances, but at lower intensity. Time feels extended. Processes that occurred quickly near the surface now unfold slowly. Growth takes longer. Change arrives gradually. This does not make the environment inactive, it makes it predictable. Light continues to fade as the descent progresses. What remains becomes dim and diffuse, scattered evenly through the water. At a certain depth, brightness no longer changes noticeably. It simply becomes low and constant. Pressure now defines the environment more clearly than light. The weight of water above shapes every structure, every process. Temperature continues its gradual decline. The water approaches a stable cold, one that changes little across large distances. These conditions create consistency across wide regions. Unlike the surface, which varies from place to place, the Twilight Zone remains similar across much of the planet. This uniformity supports continuity. Systems here do not need to adapt quickly. They remain aligned with stable conditions. Movement becomes deliberate rather than frequent. Organisms drift, hover, or move in short bursts. Energy is conserved. The absence of strong light reduces visual complexity. The environment becomes simpler in appearance, though not in function. Nothing stands out sharply. Everything blends. The descent continues without interruption. There is no marker to signal when the Twilight Zone begins or ends. It is defined not by boundaries, but by ranges. Ranges of light, ranges of temperature, ranges of pressure. As light grows weaker, it becomes less relevant. Biological systems rely more on chemical cues, vibration, and slow movement. The water itself becomes the dominant feature, clear, cold, and dense. Particles continue to sink. Some are consumed along the way. Others continue downward, unchanged. The steady rain of material links the upper ocean to deeper regions. Energy travels vertically, not in bursts, but as a constant flow. The Twilight Zone serves as a transition. It absorbs the influence of the surface and redistributes it downward. Nothing is lost. Everything is transformed. As the last usable traces of sunlight diminish, the environment prepares for complete darkness. Not suddenly, not dramatically. Just as light once faded into twilight, twilight now fades into absence. And with that absence, the ocean enters a region where illumination no longer shapes form or function, and where depth itself becomes the defining condition. At this depth, sunlight is no longer present, not reduced, not filtered, absent. The last traces of natural light have already faded above, leaving the water in a state that does not change with time of day or season. Here, Darkness is not an event, it is a condition. The ocean does not react to this absence. It continues as it did before, shaped now almost entirely by depth, pressure, and temperature. The water remains clear. Darkness does not make it opaque, it simply removes visual reference. There is no horizon here, no surface glow, no shifting brightness, only uniform blackness, evenly distributed in all directions. Pressure continues to increase, steadily and predictably. The weight of the water above presses inward from every side, balanced and constant. There is no single direction of force. Everything is held in equilibrium. Temperature has settled into a narrow range, cold but stable. The kind of cold that does not fluctuate, that does not surprise. Movement still exists, but it is minimal. Currents persist, driven by density differences rather than wind or heat. They move slowly, carrying water masses across long distances without turbulence. In the absence of sunlight, energy arrives only indirectly. Material produced in upper layers continues its slow descent. Particles drift downward through the darkness, linking this zone to the surface far above. Nothing falls quickly. Nothing arrives all at once. This steady input supports life that operates at low energy levels. Population density here is reduced, not because the environment is hostile, but because available energy is limited. Systems adjust to match supply. Organisms function efficiently, conserving resources. Movement is infrequent. Growth is slow. Vision, where it exists, does not depend on ambient light. Instead, many organisms rely on sensitivity rather than clarity. One process becomes noticeable in this darkness: bioluminescence. This light does not fill the environment. It appears in brief, localized moments, small flashes, soft glows. Bioluminescence is not decoration. It is a biochemical reaction, controlled and precise. Energy stored within molecules is released as light, producing a faint illumination without heat. These signals do not brighten the surrounding water. They remain contained, disappearing as quickly as they appear. In this zone, light is no longer a background condition. It becomes an event. The darkness remains dominant. Pressure now defines the physical limits of form. Structures are compact, materials are flexible. Nothing resists the force. Everything accommodates it. Water density is high. Buoyancy changes subtly with depth. Motion requires intention rather than momentum. Sound travels efficiently through this environment. With little interference from surface activity, vibrations move far and evenly. Communication, where it occurs, relies on these properties. Time feels extended. Processes unfold slowly. Change arrives gradually. The environment does not reward speed. This steadiness creates predictability. Conditions here vary little across large distances. Temperature, pressure, and chemistry remain consistent. In contrast to the surface, where environments shift rapidly, the midnight zone holds its state. The absence of light removes visual complexity. What remains is structure defined by physical parameters rather than appearance. The water does not feel empty. It feels uniform. Particles continue to settle. Some are consumed, others pass through unchanged. This downward movement connects the midnight zone to deeper regions still. Energy continues its descent, step by step. As depth increases further, biological activity becomes less frequent, not absent, but sparse. Movement decreases. Encounters become rare. The environment becomes quieter, not in sound, but in activity. Pressure continues to rise. Temperature remains nearly constant. Darkness remains complete. These conditions persist over vast areas of the ocean. They do not vary with latitude or weather. They exist beneath all surface conditions. The midnight zone spans much of the planet's ocean volume. It is not a narrow band, but a broad region of consistent darkness. Here, life exists without reference to the sky, without cycles of day or season. Processes follow internal rhythms shaped by chemistry and pressure rather than light. The descent continues. As biological density thins and motion becomes increasingly infrequent, the environment begins to change again. Not through loss of light, which is already complete, but through the gradual dominance of the seafloor itself. The water above grows quieter. The distance between active systems increases, and ahead lies a region where movement slows further still, and where the ocean's focus shifts from living processes to the long, steady presence of the earth beneath. Below a certain depth, sunlight no longer arrives at all. There is no gradual dimming here. Light does not weaken further. It is simply absent. The water becomes completely dark, not because something blocks the light, but because distance has exceeded its reach. The energy that once traveled downward from the surface has already been absorbed above. This region exists without reference to the sky. In the absence of sunlight, time feels less segmented. There are no day-night cycles, no seasonal shifts driven by changing angles of illumination. Conditions remain consistent over long periods. Temperature stays low and stable. Pressure remains high and uniform. The water presses inward from every direction. This pressure is not intermittent. It does not vary with motion or weather. It is always present. Each meter of depth adds to it, creating an environment where force is evenly distributed and constant. Structures here are shaped to function within this condition, not to resist it. Darkness does not create emptiness. Life continues, but it reorganizes. Without light, vision based on reflection becomes less useful. Other forms of sensing take precedence. Chemical detection, vibration, subtle changes in water movement. Population density decreases further. Energy is limited, arriving only from above or generated locally through chemistry. Nothing is wasted. Movement becomes measured. Organisms conserve energy, remaining still for long periods before brief, purposeful motion. In this environment, bioluminescence appears. It is not illumination in the way sunlight is. It does not fill space or reveal landscapes. It occurs as small, localized chemical reactions. Specific molecules interact, releasing energy as visible light. This light is controlled, brief and precise. It is produced only when needed. There is no excess. Bioluminescence does not replace sunlight. It functions differently. It does not shape the environment. It exists within it. The surrounding water remains dark, unchanged by these brief emissions. Pressure continues to define every aspect of this zone. The force applied here is many times greater than at the surface, yet it is evenly balanced, pressing equally from all sides. There is no sensation of crushing, only containment. Temperature remains low and steady. Heat does not fluctuate. Energy exchange occurs slowly. The water column above insulates this region from surface variation. Storms, Winds and waves no longer register. Sound becomes one of the few signals that can travel distance. Low-frequency vibrations move through water efficiently, carrying information across space. Even so, the environment remains quiet. Processes unfold at a slow pace. Growth takes time. Reproduction occurs infrequently. Nothing here is hurried. Food arrives gradually. Organic material continues to sink from the upper layers, passing through this region in small amounts. Some of it is intercepted. Some continues downward. This constant minimal input sustains systems that operate close to equilibrium. Chemical gradients remain stable. Oxygen levels are lower but consistent. Nutrients circulate slowly. The absence of sunlight does not signal an end. It signals a shift in how energy is accessed and used. Biological systems here rely on efficiency rather than abundance. They function within narrow margins. Forms become simpler in motion, though not necessarily in structure. Movement is limited because it must be justified by energy gain. The water itself feels heavier, not because of increased density, but because of reduced motion. Currents are weak and persistent. They move slowly, guided by differences in temperature and salinity rather than surface forces. This creates long-term stability. The midnight zone extends over vast vertical distances. Kilometers of water share similar conditions. Across these depths, the environment remains consistent. Dark, cold, pressurized, and still. Life does not cluster densely, it disperses. This dispersion reduces interaction. Encounters are rare. Processes occur independently. The environment does not encourage rapid change. It preserves continuity. Bioluminescent events remain isolated. They appear and disappear without altering the surrounding darkness. No region becomes permanently illuminated. The water remains unchanged. As depth increases further, even these sparse signs of biological activity become less frequent. Motion declines. Energy availability decreases. The environment transitions again, not by introducing something new, but by reducing what remains. Pressure continues to increase. Temperature remains stable. Darkness persists. What changes is the frequency of movement. Organisms become fewer. Distances between them grow larger. The water column stretches downward into regions where biological presence becomes minimal. This gradual thinning does not signal absence, it signals approach. Approach toward a zone where processes slow further, where time stretches even more, and where geological forces begin to outweigh biological ones. The midnight zone does not end abruptly. It tapers. As biological motion diminishes and stillness becomes more prominent, the ocean prepares for its deepest expanses. Below, the water continues. Cold, dark, pressurized, and increasingly quiet as the living layers give way to regions shaped primarily by rock, sediment, and time. And then, the movement thins out even more. Not suddenly, not dramatically, it just slows. Below the layers where light once faded, below the drifting flashes of bioluminescence, the ocean opens into something different, something wide, something steady. This is where the seafloor stretches out, the Abyssal Plains. They are not trenches, they are not mountains, they are not dramatic in shape or form. They are vast, nearly flat regions of the deep ocean floor, extending for thousands of kilometers. In fact, they make up one of the largest environments on Earth, larger than continents, larger than forests, larger than deserts, and yet almost no one ever sees them. Here, depth is measured not in meters, but in thousands of them. 4,000 meters, 5,000, sometimes more. Above this place lies a column of water heavier than any structure humans have ever built. Pressure here is constant. At these depths, the pressure reaches around 400 times the pressure at sea level. That is roughly 400 atmospheres. Every square centimeter carries the weight of several tons of water. Not fluctuating, not pulsing, just always there. There is no sensation to describe, no tension to emphasize. It is simply the background condition of existence in this layer of the ocean. Temperature is steady too, just a few degrees above freezing, not changing with seasons, not warmed by sunlight, not stirred by storms. Day and night have no meaning here. Time does not announce itself through light or shadow. The environment stays the same, hour after hour, year after year. And because of that, motion becomes rare. Water still moves, but slowly, very slowly. Deep currents slide across the plains at speeds measured in centimeters per second, sometimes less. There are no waves, no surface-driven turbulence, no sudden shifts. What happens here happens on long timescales, very long ones. Particles drift down from above, tiny fragments of organic material, bits of mineral dust, microscopic shells, traces of life that once lived closer to the surface. This slow rain never stops, but it is almost impossibly gentle. In a year, only a thin layer settles. In 1,000 years, still just millimeters. Over millions of years, these particles build up into thick blankets of sediment, smoothing the seafloor even further. This is how the Abyssal Plains become flat, not through force, not through collapse, but through patience. Layer after layer, settling quietly. Nothing rushes, nothing interrupts. And life here adapts to that steadiness. There are living organisms on the Abyssal Plains, but they are few and they move little. Many remain in place for long periods of time, conserving energy in an environment where new energy arrives slowly. Food is scarce but predictable. It comes from above, not from local production. There is no photosynthesis here, no sunlight, no primary energy generation. Everything depends on what sinks down. So biological activity becomes minimal. Not absent, just restrained. Movements are deliberate. Growth is slow. Reproduction happens on long cycles. The entire system operates at a reduced pace, matching the calm of its surroundings. Even sounds, if there were ears to hear them, would be rare. There are no breaking waves, no storms, no crashing motions. Just the quiet consistency of pressure, cold, and time. This environment does not change quickly. It does not respond dramatically to events above. Surface storms pass without notice. Seasons come and go without effect. Years mean little here. Even centuries barely register. This is one of the most stable environments on the planet. And that stability is not accidental. It is the result of distance. distance from the sun, distance from the atmosphere, distance from most sources of disturbance. Here, the ocean becomes less about motion and more about persistence. The plains extend across ocean basins, forming a continuous layer beneath the dynamic world above. They are the backdrop against which other features stand out. Seamounts rise from them, trenches cut through them, but the plains themselves remain. Flat, wide, unchanging. Sediments continue to fall, a constant, nearly invisible snowfall of particles. Some originate from plankton shells, some from distant deserts carried by wind, then washed into the sea. Some from volcanic ash scattered across the globe before settling here. All of it ends up in the same place. All of it adds to the slow record of time. Each layer tells a story, not through events, but through accumulation, through chemistry, through composition. And while biological motion fades, another kind of activity becomes more important: geological presence. The seafloor here is part of Earth's crust. It moves, but on scales far beyond daily life. Tectonic plates slide at rates of centimeters per year. Heat from the planet's interior escapes gradually through the rock. Nothing abrupt, nothing loud. Just a slow, continuous exchange between the deep Earth and the deep ocean. This is where the ocean starts to feel less like a habitat and more like a setting, a stable platform upon which change happens elsewhere. Above, life flashes and fades. Populations bloom and collapse. Currents shift with climate. Ice ages come and go. Down here, the plains remain. That constancy is not emptiness. It is structure. It provides a baseline, a reference point, a place where variability drops away and long-term processes take over. When scientists study these regions, they do not look for sudden discoveries. They look for patterns stretched across millions of years. They read the sediments like pages stacked on top of one another, each one thin, each one quiet. There is comfort in this layer of the ocean. Not excitement, not mystery, but reliability. The idea that somewhere on Earth, conditions remain nearly the same for spans of time that exceed civilizations. The Abyssal Plains do not demand attention. They simply exist, holding the record of slow change, holding the weight of the ocean above. And as biological movement continues to thin out, as energy becomes more diffuse, the focus naturally begins to shift again. From organisms to environment, from environment to time itself. Because below this calm, below even this stability, the story of the ocean stretches further, into depths where the surface no longer matters at all, where geological forces speak more clearly than living ones. Beneath the wide, steady plains of the seafloor, beneath the slow rain of sediment and the quiet patience of deep water, something else is happening. Something even slower, something even older. Pressure is still present, unchanged, constant. 400 atmospheres pressing down, evenly distributed, not pushing in one direction, not crushing selectively. It doesn't act like a blow, it acts like a condition. Every grain of sediment feels it the same way. Every layer of rock below carries it without complaint. Pressure here is not an event. It is part of the environment, as stable as gravity. And beneath that pressure lies rock. Not loose sand, not drifting particles, but solid layers, stacked and compacted over time. The seafloor is not the end of the Earth, it is a boundary. Below it, sediments become stone, layer after layer compressed, bonded, transformed. Materials that once floated near the surface, now locked into place, forming a physical record of what the planet has been doing. These layers do not tell stories quickly. They don't react to years. They barely react to centuries. Their language is time measured in millions. Each layer represents conditions that once existed above. Temperature, chemistry, volcanic activity, biological productivity. All of it recorded quietly, without emphasis, without interpretation, just accumulation. And once formed, these layers persist. They remain even as oceans change, even as coastlines shift, even as life on the surface rearranges itself again and again. Stillness here does not mean nothing is happening. It means that what is happening happens slowly enough to feel like rest. Heat still moves upward from Earth's interior, but it does so gradually, spreading through rock over immense spans of time. The planet cools, but not in a hurry. It breathes heat on a geological schedule. Chemical reactions continue as well. Minerals transform under pressure. Water trapped in rock alters structures molecule by molecule. These changes are real, measurable, and constant. They just don't announce themselves. Time behaves differently at this depth. Minutes and hours lose relevance. Even years become background noise. When change happens on million-year scales, stillness becomes the dominant experience. This is where the idea of the bottom begins to lose its meaning. Because this place is not an ending, it is a continuation. The ocean rests on rock, the rock rests on deeper rock, and all of it rests on processes that began long before oceans existed at all. The stillness here is not empty, it is persistent. Pressure keeps everything in place. Temperature remains steady. Motion exists, but only in forms that require patience to notice. This environment does not invite reaction, it invites observation. When scientists drill into the seafloor, they don't expect surprises in the moment. They expect gradual transitions, subtle shifts in composition, a slow turning of pages. Each centimeter downward may represent thousands of years, each meter tens of thousands. To reach layers formed in the age of dinosaurs requires drilling through an unbroken column of time. Nothing abrupt marks the passage. No sharp lines, no dramatic borders, just continuity. And that continuity reframes what depth means. Depth is not just distance from the surface, it is distance from immediacy. The deeper we go, the less the present matters. Events blur, variations smooth out, extremes soften. What remains are averages, long-term conditions, persistent forces, pressure, heat, weight, and time. So when we talk about stillness here, we are not describing inactivity. We are describing a balance that holds. A balance between downward pressure and upward resistance. Between heat rising and cold water above. Between sediment falling and rock forming. Nothing rushes this balance. It has no reason to. The Earth is not trying to arrive anywhere. It simply continues. This perspective changes how we think about motion itself. Movement does not disappear at depth. It slows until it becomes almost invisible. But invisible does not mean absent. Beneath the rock, forces are aligning. Stresses are accumulating. Plates are adjusting, millimeter by millimeter, year after year. All of this happens beneath a surface that looks completely still. And that is the quiet amazement of this place, that what appears unmoving can be active on timescales beyond perception, that what feels calm can be shaped by forces more powerful than anything on the surface. The Abyssal Plains above offered environmental stability. Here, that stability expands into geological endurance. The ocean no longer feels like a space filled with life. It feels like a layer in a much larger structure. A structure built slowly, maintained patiently, adjusted constantly, but never quickly. This is the bottom of everyday time. Below it, the planet operates on its own clock. And as we stay here, suspended between water and stone, the idea of change becomes softer, less urgent, less dramatic. Change does not need to announce itself to be real. Sometimes it only needs enough time. And beneath this stillness, beneath these quiet layers, the Earth continues to move in ways that are almost impossible to feel, even as everything above rests upon it. The rock beneath the seafloor is not a single unbroken surface. It is divided into vast plates, each one carrying part of the planet's outer shell. These plates fit together loosely, not like puzzle pieces snapped into place, but like slabs resting side by side. Most of these boundaries lie beneath the ocean. They do not announce themselves from above. The water above them remains calm. The Abyssal Plains show no sign of what lies below. But far beneath the sediment, the plates continue to move. Slowly. So slowly that motion becomes a matter of record, not sensation. A few centimeters each year, sometimes less. At that pace, a human lifetime barely registers. Even centuries leave only small adjustments. But over millions of years, this movement reshapes entire basins. Along mid-ocean ridges, plates move apart. Molten material rises from below, cools, and becomes new seafloor. This is not an eruption in the usual sense. There is no sudden release, no violent disruption. It is steady production. Rock forms, cools, and spreads outward. Older seafloor is pushed away, making room for what comes next. The ocean floor grows, very gradually, like a surface that renews itself without pause. The rate is consistent, predictable, measured carefully. On the other side of the plates, the opposite process occurs. Subduction zones mark where one plate slides beneath another. The denser plate sinks slowly back into the mantle. Rock descends. Heat increases. Materials change state. Again, nothing abrupt marks the transition from one phase to the next. There is no moment where the plate suddenly gives way. It bends, it descends, it disappears over immense spans of time. Above these boundaries, the abyss remains quiet. No waves, no currents, no visible disturbance. The ocean does not mirror the motion below it. Water and rock operate on different clocks. This separation is what allows stability to exist alongside motion. The environment feels calm because change is spread thin. It is diluted across distance and time. No single moment carries the weight of transformation. Instead, change accumulates. Each year adds a fraction. Each century adds a trace. Each million years reshapes geography. What we call continents, basins, and ridges are not static features. They are temporary arrangements in a process that never stops but never rushes. The Abyssal Plains sit on crust that was once molten. They rest on rock that formed far from where it now lies. Their flatness is not original. It is the result of motion, cooling, and sedimentation working together. Motion creates elevation. Sediment smooths it out. Over time, peaks fade, valleys fill, irregular surfaces become even. This is not erosion in the dramatic sense, it is adjustment, a balancing act between forces that act at different speeds. Tectonic movement introduces variation. Sedimentation reduces it. Neither wins, both persist. This balance explains why the deep ocean floor looks the way it does. Not chaotic, not jagged, but broad and level, with features that stretch for hundreds of miles. Nothing here was designed to be smooth. Smoothness is the result of time being allowed to do its work, and time is abundant. The slow motion of plates does not seek outcomes. It follows physical constraints, density differences, heat flow, gravity. There is no urgency. When two plates meet, the interaction unfolds at the only pace available to rock under pressure, millimeter by millimeter, grain by grain. Stress builds, yes, but release, when it comes, is still governed by deep structure, not surface drama. Earthquakes may be felt far above, but at depth, they are part of a longer process. Adjustments along boundaries that have been forming for tens of millions of years. From the perspective of the abyss, even sudden events are brief interruptions in a much larger continuity. The dominant experience remains stability. Temperature changes little. Pressure remains constant. Chemical conditions stay within narrow ranges. The rock moves, but the environment holds. This is what allows the ocean floor to support long-term processes without disruption. It is what allows layers to remain intact, records to persist, and patterns to remain readable. Motion does not erase stillness here. It exists within it. The idea of change becomes less dramatic and more dependable. Less about moments, more about direction. Plates will continue to move whether observed or not. New crust will continue to form. Old crust will continue to descend. The abyss does not react. It accommodates. And this quiet respect for continuity is the deeper lesson of this place. That transformation does not require urgency. That movement does not require noise. That the planet can reshape itself without disturbing the calm above. As we remain here, suspended between water and stone, motion no longer feels like something that interrupts stillness. It feels like something that belongs to it. And beneath this slow movement of rock, beneath boundaries that slide and spread almost imperceptibly, another set of processes continues. Not mechanical, but chemical. Not structural, but thermal. Processes driven by heat, by fluids, by reactions that take place far below the reach of light. Processes that operate on the same patient schedule. And they wait just a little deeper still. The movement of plates does not end at their boundaries. Where rock pulls apart, where it sinks, where heat rises slowly from deeper layers, water finds a way in. Seawater seeps downward through cracks in the crust. It does not rush. It follows pressure differences, guided by fractures that have opened over long spans of time. As the water descends, conditions change. Temperature increases steadily. Pressure remains high and constant. Minerals dissolve into the fluid. The water does not boil in the way it would at the surface. Pressure keeps it in liquid form, even as it grows hotter. Chemical reactions become possible. Elements separate, recombine, and concentrate. Eventually, the fluid turns back upward. It rises through the same fractured rock, carrying heat and dissolved minerals with it. When it reaches the seafloor, it meets cold ocean water. This meeting creates hydrothermal systems. Not dramatic in appearance, not widespread, simply consistent where conditions allow. The water emerging from these vents is warmer than its surroundings, sometimes much warmer. But temperature alone is not the defining feature. What matters is chemistry. The fluid contains hydrogen sulfide, methane, iron, and other reduced compounds. These substances carry energy in their molecular bonds. When they mix with oxygenated seawater, chemical gradients form. Energy becomes available, not from sunlight, not from photosynthesis, but from chemical imbalance. Certain microorganisms are able to use this energy directly. They do not rely on light. They do not depend on surface productivity. They carry out chemosynthesis. Chemical reactions drive the formation of organic molecules. Carbon is fixed. Energy is stored. Growth becomes possible. This process does not compete with photosynthesis. It operates independently, in parallel, under conditions that remain stable for long periods. The organisms involved are small, mostly microbial. Their activity is steady rather than explosive. They form the base of localized ecosystems. Larger organisms may gather nearby, but they are not the focus here. What matters is the system itself. The way heat, water, and rock interact to sustain chemistry over time. These environments are limited in size. A vent field may extend for a few hundred meters, sometimes less. Beyond that, conditions return to the uniform cold of the Abyssal Plains. There is no expansion outward, no takeover of surrounding space. The system remains contained. This containment contributes to stability. The reactions proceed at rates that match the flow of fluids. Heat dissipates gradually. Minerals precipitate slowly, building structures that grow and change over time. Chimneys form as dissolved materials solidify on contact with cold seawater, layer by layer, particle by particle. They are not permanent. As fluid paths shift, as mineral buildup blocks channels, old vents shut down, new ones open nearby. The system migrates without spreading. Everything operates within limits. Pressure remains extreme. Temperatures vary sharply over short distances. Chemical concentrations fluctuate. Life here does not resist these conditions. It functions within them. Biochemical processes proceed only as long as balance holds. Enzymes operate within narrow ranges. Membranes maintain integrity only under specific pressures. Nothing is robust in the casual sense. Yet nothing is fragile in the dramatic sense either. The system persists because it is regulated by physical constraints. Flow rates, heat output, and chemical availability all act as controls. When conditions drift outside usable ranges, activity slows or stops, and then it resumes elsewhere. This pattern has repeated for millions of years. Long before surface ecosystems reached their current complexity, chemical energy systems existed at depth. They did not replace other forms of life. They existed alongside them, quietly. The ocean floor does not prioritize one energy source over another. It accommodates what conditions allow. In this way, hydrothermal systems are not exceptions. They are expressions of the same continuity seen elsewhere. Movement of plates creates heat. Heat drives fluid flow. Fluid flow enables chemistry. Nothing is isolated. The abyss remains largely unchanged by these processes. Vent fields occupy a small fraction of the seafloor. Their influence fades quickly with distance. Temperature returns to near freezing. Chemical concentrations drop back to baseline. Darkness remains complete. From a broader perspective, the ocean floor continues to feel uniform. And yet, within that uniformity, these systems operate steadily, linking deep geology to living chemistry. They demonstrate that energy does not need to arrive quickly to be useful. It does not need to be abundant. It only needs to be reliable. Reliability is what defines this environment. Heat output remains within bounds set by the planet's interior. Water circulation follows gravity and pressure. Chemical reactions proceed according to basic physical laws. Nothing here is improvisational. The slow pace continues. Years pass without noticeable change. Decades add only slight adjustments. Over thousands of years, vent structures grow, collapse, and reform. Over millions of years, entire systems migrate along plate boundaries. The surface remains unaware. Above, currents move, seasons shift, climate varies. At depth, the schedule stays the same. Hydrothermal systems do not introduce urgency into the abyss. They reinforce its rhythm. They show that even where energy is concentrated, it is delivered gradually. Even where heat escapes from the planet's interior, it does so under control. This reinforces a larger idea. The deep ocean is not defined by extremes. It is defined by consistency. Pressure is high everywhere. Temperature is low almost everywhere. Darkness is complete. Within that framework, variation exists, but it does not disrupt the whole. Chemical energy systems fit into this pattern without altering it. They add detail without changing the overall tone. And as these processes continue, year after year, they connect the deep ocean floor to something larger than any single vent or boundary. They connect it to the planet as a system. Heat rising from the interior, rock cycling through formation and descent, water circulating between crust and ocean. Nothing here operates in isolation. The abyss is not separate from the rest of Earth. It is part of a continuous exchange that spans surface and depth, biology and geology, motion and stillness. And as this exchange continues, quietly and steadily, it opens into a view that extends beyond individual processes, toward the idea of Earth itself, operating over spans of time that exceed any single environment, toward continuity on a planetary scale. Over long spans of time, the ocean does not act as a separate place. It operates as part of a larger system that includes rock, air, and heat moving through the planet. Water covers most of Earth's surface, but more importantly, it occupies much of Earth's active volume. It circulates heat, it dissolves gases, it transports chemicals between layers. This movement is slow, not in days or years, in thousands and millions of years. The chemistry of the ocean changes gradually as water interacts with the crust below. Minerals dissolve into seawater at mid-ocean ridges. Others are removed as sediments settle onto the sea floor. Carbon moves through this system continuously. It enters the ocean from the atmosphere. It reacts with water. It becomes part of dissolved compounds. Some of it settles to the bottom, locked into sediments. Some of it is returned to the surface through circulation. This exchange does not pause. It does not respond to attention or absence. It proceeds according to physical balance. Temperature regulation follows a similar pattern. The ocean absorbs heat from the atmosphere and redistributes it through currents that move across basins and through depths. Warm water rises, cold water sinks. Density differences drive circulation that connects surface and abyss. This circulation takes centuries to complete a full cycle. A molecule of water sinking near the poles may not return to the surface for hundreds of years. During that time, it carries heat, oxygen, and dissolved elements into deep layers. Nothing rushes. The sea floor plays its role quietly. Sediments accumulate. Layers build up slowly, recording changes in chemistry and climate over long intervals. Each layer represents a period when conditions were slightly different. Temperature, atmospheric composition, biological activity. Stacked together, these layers form a record that spans much of Earth's history. Below them, the crust continues to move. Plates separate. Plates collide. New seafloor forms. Old seafloor sinks back into the mantle. This process renews the ocean floor on timescales of tens to hundreds of millions of years. No section remains unchanged forever, and yet the ocean itself persists. Basins shift, coastlines move, depths change, but water continues to occupy the low points of the planet's surface. As continents drift, ocean circulation adjusts. Pathways open and close. Heat transport shifts gradually. Climate responds over long periods, not through sudden changes, but through accumulated effects. The ocean moderates these changes. It absorbs excess heat. It stores carbon. It releases both slowly. This buffering effect does not eliminate variation. It smooths it. Even during periods of global change, the deep ocean remains comparatively stable. Temperature variations at depth are small. Chemical conditions shift slowly. The abyss does not experience seasons. It experiences eras. Above, environments transform. Ice advances and retreats. Forests expand and contract. Species appear and disappear. Below, pressure remains constant. Darkness remains complete. Water temperature changes by fractions of a degree over thousands of years. The stability allows continuity. Processes begun long ago continue without interruption. Chemical cycles remain intact. Geological movements proceed at their measured pace. No single event defines the deep ocean. It is shaped by accumulation. Grain by grain, sediment settles. Layer by layer, rock forms. Molecule by molecule, chemistry adjusts. Even large-scale disruptions are absorbed into this slow rhythm. Volcanic activity introduces new material. Circulation redistributes heat. Chemical balances shift and then stabilize again. Nothing stops. Nothing accelerates dramatically. The ocean does not require observation to function. Its systems were operating long before human presence. They will continue regardless of attention. This is not indifference. It is simply scale. The timescales involved exceed individual lifetimes, civilizations, and species. When viewed from this perspective, the deep ocean is not empty. It is occupied by processes rather than events, by continuity rather than moments. The Abyssal Plains, the tectonic boundaries, the hydrothermal systems, all of them participate in a planet-wide exchange that has no central point. Water moves between surface and depth. Rock cycles between crust and mantle. Gases move between ocean and atmosphere. Energy flows steadily, constrained by physics. Nothing here seeks resolution. The system does not build toward a conclusion. It maintains balance through ongoing adjustment. This balance is not static. It is dynamic, but slow. Change occurs through repetition. A pattern repeats with slight variation over spans of time that blend into one another. In this way, the ocean becomes a long-term regulator, not through control, but through capacity. Capacity to store heat, capacity to dissolve gases, capacity to absorb change without abrupt response. The deep ocean does not erase disturbances, it integrates them. Over time, differences are distributed, extremes are softened. New conditions become part of the baseline. From the seafloor upward, this integration continues. Currents link deep and shallow waters. Chemical signals move upward. Heat is exchanged. The boundary between deep ocean and surface is not fixed. It is permeable, shifting, gradual. Everything connects. And yet, from within the deep, this connection feels distant. Motion is minimal. Variation is subtle. The environment remains consistent. This consistency is what allows the ocean to operate across Earth's lifetime. As continents rearrange and climates shift, the deep ocean remains present, adapting slowly, maintaining continuity. It does not record history in moments, it records it in layers. The planet changes, but it does not reset. It carries forward what came before, and the ocean, occupying so much of Earth's volume, carries much of that continuity within it. The processes unfolding at depth do not seek recognition. They proceed quietly, steadily, without pause. And as this steady motion continues, it leads naturally away from individual systems and toward a broader sense of scale, a sense of Earth as a whole, operating over time frames that stretch far beyond any single point of focus. A system in motion, yet never in a hurry. A continuity that remains, even as everything else changes. 4. CTA/ending. The deep ocean does not mark an ending point. It connects outward, gradually, into larger systems that extend across the planet. Water that rests at great depth today will, over long spans of time, move again. Slowly rising, slowly circulating, joining currents that pass through basins and along continental edges. Nothing signals the moment when this happens. There is no boundary, only gradual movement driven by temperature, density, and gravity. Sediment continues to fall. Tiny particles settle through kilometers of water, reaching the seafloor after years or decades. Each particle adds a nearly invisible layer. Over long periods, these layers accumulate, recording shifts in climate, chemistry, and circulation. This process does not pause. It continues whether the surface is calm or storm-driven. whether coastlines change or remain familiar. Below, tectonic motion persists. Plates drift at measured speeds. New crust forms where plates separate. Older crust sinks where plates converge. This exchange reshapes the seafloor without urgency. Centimeter by centimeter, the planet adjusts. Chemical cycles move through these layers as well. Elements dissolve into seawater. They are transported by currents. They settle. They react. They return to solid form. Carbon follows this path repeatedly, moving between atmosphere, ocean, and rock over spans of time that exceed memory. Heat does the same, absorbed at the surface, distributed through depth, released gradually, stored for centuries before returning. These exchanges smooth variation. They do not prevent change. They extend it across time. From this perspective, Earth does not experience moments. It experiences intervals. The ocean supports this continuity by occupying so much of the planet's volume, by slowing processes that might otherwise occur abruptly, by storing energy and matter within deep layers. This role does not require coordination. It emerges from physical properties: density, solubility, heat capacity, pressure. These forces operate continuously. Above, life responds to seasons and cycles that repeat within years or decades. Below, conditions change so slowly that individual variations become indistinguishable. Temperature remains nearly constant. Darkness remains complete. Pressure remains uniform. In this environment, the idea of interruption loses meaning. Events that would be noticeable elsewhere become absorbed into long-term patterns. A volcanic eruption introduces new material. Circulation distributes it. Sedimentation incorporates it into the seafloor. Over time, the disturbance becomes part of the background. The ocean does not reset. It carries forward accumulated change. This continuity extends upward. Surface waters exchange gases with the atmosphere. Winds drive currents. Ice forms and melts. Heat moves between layers. All of these processes link surface and depth. The connection is gradual but constant. Nothing exists in isolation. The deep ocean is connected to polar regions, tropical waters, continental shelves, and open basins through circulation that spans the globe. These pathways remain active regardless of observation. They operated before modern measurement. They will continue without it. The system does not require attention. It functions through balance, through adjustment rather than response. As time passes, coastlines shift, continents drift, sea levels rise and fall. The ocean adapts. Basins deepen or become shallow. Circulation patterns adjust. Chemical balances shift. But water remains present. It occupies the lowest regions of the planet's surface, reshaped but continuous. From this scale, presence becomes less about visibility and more about persistence. The ocean persists through change. Its deepest regions are not separate from the surface. They are part of a connected whole, operating across multiple timescales at once. Short-term motion at the surface, long-term stability at depth. Together, they form a system that extends across Earth's lifetime. This system does not reach a conclusion. It continues. Sediment continues to settle. Plates continue to move. Chemical exchanges continue to cycle. No single process defines the whole. There is no central point of control, no moment of completion. Only ongoing motion, constrained by physical limits, extended across time. From this perspective, the presence or absence of observers does not alter the process. The ocean does not change its pace. It does not accelerate. It does not slow. It remains steady. And in that steadiness, it offers a kind of continuity that does not depend on participation. A continuity that exists regardless of awareness. As the focus broadens outward, the details soften. Individual features become less distinct. The emphasis shifts from parts to patterns. Patterns of circulation, patterns of exchange, patterns of gradual change. These patterns do not resolve. They repeat with variation across eras. The deep ocean remains part of this repetition, not as a boundary, not as an endpoint, as a volume through which Earth continues to operate. Over time, everything above adjusts to what happens below, and everything below responds slowly to what happens above. The exchange never stops. From the deepest seafloor to the highest atmosphere, Earth functions as a connected system. No section operates alone. No layer exists in isolation. The ocean holds much of this connection within it, quietly, steadily. Its depth allows time to stretch. Its mass allows change to diffuse. Its continuity allows processes to persist. And so the world continues, not toward a conclusion, not toward a final state, simply continuing, layer by layer, cycle by cycle, across spans of time that extend far beyond any single moment. And within that continuity, there is no urgency, only steady motion, only persistence, only the ongoing presence of a system that remains, even as everything within it slowly changes.